Okay, if we look at our unsigned char line here, which is a relationship really between hexadecimal and decimal, what we find is that we do certain calculations, we're going to run into trouble. Because if we say FF plus 1, and the calculation isn't that difficult, it's 0, 0 plus a carry. Well, what does this really mean? It means I had $255, say, I get another dollar, and now I've got only $0. I got nothing. Because our variables are going to be char variables that these things are contained in, or answers, and this result of extra 9th bit here, or carry, will not fit into a char or 8-bit variable. So we've lost some of our data here, so FF plus 1, this carry here indicates something called an unsigned overflow, because our number is too big to fit into our 8 bits. Let's take a look at another calculation. Let's look at 0.3 subtract 0.5. So if we do the calculation, it's the lazy Joe and hardworking Bob scenario again. Joe needs money, Bob doesn't have any, so he sends him to the bank, he gets 1, he's now got 16, Joe hits him up for a loan. Poor old Bob has got 15, now he's got 16 plus 3, so that's 19 minus 5 is what, 14, which is E, FE. And so what does this mean? What this means is I went 3 units this way, and I turned around and I went 5 units this way, and I wrapped all the way around here to FE. What that means is I said 3 subtract 5 is 254. It doesn't make sense. So anytime you have a carry or a borrow, what this really means is an unsigned overflow. And an unsigned overflow means that the result is not valid as an unsigned char. Now you're going to run into these kinds of circumstances if you get digitizing values. For instance, if FF is 10 volts, and you had a very small voltage, you're going to end up with a very small voltage, almost 0. So adding 10 plus a little bit gives you a small voltage, doesn't make sense. So in code, when you're digitizing something, you say, if my A to D value here, when I add it, ends up being smaller, I can make this my maximum, which in this case would be 10 volts. So there is ways to get around it, but we do have something called unsigned overflows for unsigned char. So every time you see a C equals 1, and that's what you're going to see in here, whether you do a carry or borrow, that means you have an unsigned overflow. Now, what we saw before is we have a calculation. This is our unsigned char. This is our signed char. And what we saw before was we had a calculation FF plus 1. And what we saw was this was a carry and a 0, 0 because it could not be represented properly in our unsigned line. However, FF plus 1 is not a problem here because FF is -1 plus 1 is 0. It makes perfect sense. So for our signed char, the carry is not how we determine whether or not we have a signed overflow. So let's take a look at how that works. For instance, if I do this math, 7F plus 1. If you look at that, that's 80 plus no carry. Let's look at this calculation up here. 7F plus 1 is 80. Makes perfect sense, and no carry here says I did not go past the bounds of my unsigned numbers. However, let's take a look here at our signed chart. Signed chart 7F is 127. I have $127. Somebody gives me another dollar, and I'm $128 in the hole. This is a problem. How's that? Well, this is a positive plus a positive, and I got a negative result, which doesn't make any sense at all. Okay? So, what we're going to say is, what about the other end? If I say 80 plus FF, if we do that calculation, we see 7F plus a carry, which means I'm as far in debt as I can go. I go another dollar in debt, and then I have all the money in the world. And this doesn't make sense because this is a negative plus a negative, and I didn't get a negative, I got a positive result. This is called a signed overflow. B equals 1 indicates we have a signed overflow. And the concept of a signed overflow is quite simple. If If you add a positive to a positive and you go past the positive end, that is a signed overflow. If you add a negative to a negative and go past the negative end, then this is a signed overflow because the number will not fit in our signed line. So how do we write this up? Basically, for a signed overflow, if you add two numbers of the same sign, and get a result of opposite sign. So this is what a signed overflow is.